Hello guys, you're welcome back to my channel Fun with Physics. In today's lesson, we are going to look at dispersion of white light and then briefly consider colors. Now as a starter, look at the screen that you have. Why is the screen black? How about this? Why is part of the screen white? At the end of this lesson, you'll be able to tell why this is black and then this is white. Okay? Now let's get some facts about light, white light. Light travels at a very fast speed, which is about 300 kilometers per second. That is to say that at this speed it can go around the world 8 times in 1 second. Think about that. Now another fact is this: we see things because they reflect light into our eyes, like what you have here. So if you're observing whatever you're observing, looking at, it means light from a source hits that object and then it's reflected to your eyes. Now let's look at some important summary about light, the properties of light. Number one, light travels in a straight line. Number two, light travels much faster than sound. We see things because they reflect light into our eyes. And then shadows are formed when light is blocked by an opaque object. Okay? Now, dispersion of white light, what does that mean? White light is not a single color at all. It's made up of mixtures of 7 colors. That's the color of the rainbow. And for you to see the color clearly, you need a prism and then a source of white light. Okay, now when the light hits a prism, the prism of course is going to disperse it into several colors. That's the colors of the rainbow. This is how rainbows are formed, in case you observe one. Sunlight of course is split up by raindrop. We're going to look at that later. So what does dispersion stand for? What do we mean by that? When white light is refracted through a prism, the color, or what we sometimes call the spectrum, separates out because it moves slowly through the glass, and that is what we call dispersion. So dispersion generally is a splitting or the separation of the component colors of white light, which we otherwise call the spectrum. Okay, now the spectrum. If you have the prism here, and then the source of white light, the prism will be able to separate the colors, the different colors of white light, into these colors: red, orange, yellow, green, blue, indigo, violet. Okay, so you can easily remember this using Roy G. Biv. Okay, that's taking the initial ROYGBIV. Now, explanation of dispersion. Why does it occur? Why do the prism split this white light into several colors? Now, the reason is this. Number one, white light is made up of several colors which travel at different speed in glass or in a prism like this. Okay, now because they travel at different speed, they will be refracted by different amounts, or in other words, they have different wavelengths. Okay, now the red light that you see travel faster than the violet light that you have there. Okay, so in that way, red light is the least refracted, and then violet is the most refracted. Okay, it means the violet light has the shortest wavelength or the smallest wavelength in glass. Also, you can explain in terms of frequency too. Light, when you display this spectrum in an electromagnetic arrangement, you discover they have different frequencies. Okay, so this have the least frequency, the red light, and these have the violet has the most frequency. Okay, so these account for the separation. So we can easily explain this using speed and wavelength. Now, this light can also be combined to prove that the colors are actually from white light. So when you have an inverted prism, they can refract and focus the light to a single point. You will observe that you're going to get your white light back. Okay, sometimes you can even use a lens, a convex lens, to get the focus, to get even a better focus at this end. All right, now how is rainbow formed? This actually represents the water drops that we have in the atmosphere. So rainbow can only be formed if there is water drops or fog or something that can actually refract light in the atmosphere. So rainbow are formed when sunlight is scattered from raindrops into the eyes of an observer. So basically, this is exactly what happens. The ray of light enters the drop, it is refracted slightly. At the end of the drop, it's reflected, which is further refracted. Now the refraction here spreads out all the rainbow colors that we have in white light. Now look at what is actually happening. So we have refraction, first refraction, a reflection, and then a refraction which the observer sees. Now the observer must be in opposite direction to the water droplet before you can actually observe rainbow. Notice that the sun ray is coming from this side and then it's reflected and refracted to the eye of the observer to spread the colors that the observer sees as rainbow. Okay, so this is basically how we get to see our rainbows. Now, colors of white light. I've told you earlier that we are going to briefly look at colors and you'll be able to tell why we see the colors that we see. Now, we see white light because all of the colors in the spectrum are being absorbed, are being reflected. Sorry. So when all the colors in white light is reflected back to our eyes, we tend to see it as white light. Think of it this way. You're combining all the colors together. All the colors are being combined. So what do you get to see at the end? White, isn't it? So that's why we see this color, white color. But we get to see black when all the colors are absorbed. So black, we can say, is the absence of color. So when the colors are absorbed by the object, then the object will appear to be black. So in other words, when all the wavelengths of all the colors are absorbed, no wavelength at all is reflected, then the object is going to appear to be black. Adding colors. We can have different colors of white light to form other colors. But first, we need to identify the primary colors or the basic colors of light. Now, these are the basic colors, or what we call the primary colors. So the primary colors are what we have here. We have the red color, we have green, and then we have blue. These are the primary colors. When you add these two primary color, red and blue, you get to have a different color which we otherwise called a magenta or purple. When you add red and green, you get to have yellow color. And then when you add blue and green, you get to have a cyan color. Okay, like what we have here, this color. Now this is those colors that we get by adding other colors are referred to as secondary colors. Okay, now notice that we are adding here, so we call it addition of color. We're adding two different colors to get a secondary colors, so we generally term it as a color addition. Now look at this. How about in the case where you add red and cyan? What is going to be the product or the result? The result, of course, is going to be white. Now this is because cyan is a combination of blue and green. So in other words, we're like adding the primary colors together. And notice that from this picture here, when you add this, and this, you get to have your white. Also, if you try to add all the secondary colors, you get your white. When you add blue and yellow, you get white as a product, because yellow is a combination of green and red. Okay, why is it important, or where is it important that the three primary colors make up all of the colors in a color television, or in the eyes, or in inkjet printers? These are areas where it's very important. In the eyes, for instance, we have the rods that detects light, and then the cones that detects different colors. Okay, now these cones can add up the primary colors to get other colors which will be interpreted by the sense, by the brain. Okay, the same thing applies to TV, where we have the basic or the primary colors which are combined to form other colors. Seeing colors. The color an object appear depending on the color of the light it reflects. For instance, a red book only reflects red light, like what we have here. So if this is a red book, it reflects only red light. That's why we see it as light. It reflects light of wavelength associated with red. Okay, now this is white light, a combination of all the colors, and then we get to see only red because this material actually reflects red, or reflects the wavelength that is associated related to red light. A pair of purple trousers would reflect purple light. Remember, purple is a combination of red and blue. A white hat would reflect all the 7 colors, because all the 7 colors, of course, the combination gives us white light. So remember, in this case, red and blue gives us purple, isn't it? Or magenta. Using colored light, if we look at the colored object in colored light, we see something different. For example, consider a football kit like this. When you have white light on football kit that is made up of red and blue, the shirt get to look red, and then the shorts get to look blue. Okay, because the light source that hits it, it's actually white light. But when you have a different case like this, in a different situation, here you have just a red light. The red shade will actually reflect red. We'll see it as red. But then the short will reflect nothing. So we'll see it as black. It means the short, which was originally blue, absorbs the red. It means if I use a red light on a different colored object, the red light will be absorbed. So different colored objects actually absorb light that are not related to their color, that are not close to their color. Okay, that are not having the same wavelength. Now, if you have a blue light on a blue shirt and a red shirt and a blue shirt, you get to see the shirt as blue, but then the shirt as black. This is because the red shirt will absorb all the colors here, will absorb all the blue colors and reflect nothing. Okay. Why does a red snooker ball look red in white light? Now the reason is because all of other colors are absorbed, or all other wavelengths are absorbed except the wavelength that is related to red. Okay, all other colors are absorbed except red. Now we can use the idea of what we had before to complete this exercise. It's a simple one. You can pause the video and then try to see how many of these that you can actually solve. But notice that magenta book will reflect two colors. A magenta book is going to reflect blue, and it's actually reflecting blue and red color. That's why you see it as magenta. So a red light on a magenta book will appear red because part of the color is being reflected. Okay, it's one of the color that is being reflected. A blue light on a magenta book will appear to be blue, but a green light on a magenta book, the object will appear to be black. Okay, we good? All right, now guys, don't forget to like this video if it's actually meet your need, and do subscribe to my channel, and then click on the bell, the notification button there, so that you can get more of my videos. I wish you well. Have a nice day and enjoy your day.